In this problem, the left and right compartments of a thermally isolated container of length L is separated by a thermally conducting movable piston of area A. The left and right compartments are filled with 3 by 2 and 1 moles of ideal gas respectively. In the left compartment, the piston is attached by a spring with spring constant K and natural length 2L by 5 in thermodynamic equilibrium. The piston is at distance 2L by 2 from the left and right edges of a container as shown in the figure. Under above conditions, if the pressure in the right compartment is P is equal to KL by A into alpha, then the value of alpha is. So let us solve it. So the container is thermally isolated. That means no heat from outside will enter into this container. And here this piston is thermally conducting. Where it is here, thermally conducting. So thermally conducting means here temperature T1, here temperature T2, both are equal. So here temperature T, here also temperature is T. T1 is equal to T2. That is thermally conducting. One spring is there. It is attached to spring. So the spring constant is K. This total length is L. And this length is L by 2. So here pressure P1, here pressure P2. This pressure P2, this is left side, this is left, this is left, and this is right. So right hand side pressure we have to calculate, that P2 is equal to question mark. So here this K on this piston, I will draw the diagram here. This is a piston, free body diagram I am writing. I am drawing free body diagram. Piston, the spring is there. So spring is applying whenever the temperature increases, it want to go here. Then Kx value, this is the restoring this one. And here in this direction, pressure is applied. And here in this direction, pressure is there. Right? So forces, the area of the piston is A. So the force in this direction is this one, the force in this direction is this one. P into A is force formula. So these are the forces acting on a piston. So we'll write at thermal equilibrium, thermodynamic at thermodynamic equilibrium. So what happens here? P1A minus Kx is equal to P2A. Now P1A is equal to K. K is see, this is L by 2 distance, but natural length of the spring, see, natural length, spring length I may say, spring length is given as 2L by 5. But here it is stretched to L by 2. So what is X? How now the X is L by 2 minus natural length 2L by 5. This is the extension of the spring is equal to P2A. So P1A minus K L by this is a 10 5 minus 4L 5L minus 4L is L by 10 is equal to P2A. So here P2 we have to calculate. So P2 is equal to that A goes this side P1 minus K by A into L by 10. This is P2. So the system is in thermodynamically equilibrium. So thermodynamic equilibrium means temperatures also same. And the next we also know that piston is thermally conducting. So both sides the temperature is same. That condition I will use here. T1 is equal to T2. Then P1 V1 by N1 is equal to P2 V2 by N2. So here given that N1 is given as 3 by 2 mole and N2 is given as 1 mole. Here it is N1 mole, this is N2 mole. Right. So here this volume, both volumes are same. Why? Because this is L by 2, this is also L by 2. L by 2 into A, L by 2 into A, volumes are same. So here I will cancel these two volumes. Volume on both sides same. Now I need here P2 is equal to P1 value I want here. So I will write as P1. So P1 is equal to P2 into N1 by N2. So here P2 N1 is equal to 3 by 2. N2 is equal to 1. So this is P2 3 by 2. So I will substitute this value of P1 in equation 1. So what I get here, P2 is equal to P2 into 3 by 2 minus K by A L by 10. This is what I got. So P2 I want to calculate. So K by A L by 10 I will send that side. So KL by 10A I will write is equal to P2 P2 3P2 by 2 minus P1. So here 2P1 minus, this is P2, this is P2. So 3P2 minus 2P2 by 2. So this is P2 by 2 is equal to KL by 10A, 2 ones, 2 5s. So P2 value came KL by 5A. So in the problem they have given it as a problem. In the problem they have given this value as KL by A into alpha they have given. So from this what we can write, alpha is equal to 1 by 5, that is equal to 0.2. So this is our answer. So for question number 13, The answer is 0.0